All right, by now you've learned to think about angles in terms of radians, not just in terms of degrees. It's really important for this because I'm going to be referring to angles in terms of, I'm going to be saying pi by 4 instead of saying 45 degrees. I'm going to be saying pi by 2 instead of 90 degrees, and so on and so forth. Pi by 6 will be 30 degrees. Pi by 3 will be 60 degrees. So if you're not familiar with radians, please go back and watch the video that talks about radians. It's very thorough and it's an excellent video, so I really encourage everyone to really understand well before you start watching this video. Now you'll see here there's a circle with a radius of 1. So to the right you see the point 1 comma 0. That means we're exactly 1 to the right. 0 comma 1, which means we're up 1 from the origin, and negative 1 comma 0 to the left, which means we're 1 to the left, and 0 comma negative 1 down, which means we're 1 down. So we have it on the Cartesian plane, and this is just a unit circle. So all the way around, the radius in every direction is always going to be 1. In this video, I'm going to give you a couple different ways of thinking of sine of theta and cos of theta, but in terms of radians, and it's just going to be a refresher from grade 11. But you know, there's a whole bunch of different ways of thinking about sine theta and cos theta. You can think of it in terms of triangles, where sine theta is opposite over hypotenuse and cos theta is adjacent over hypotenuse, or you could think of it as in terms of a graph or a unit circle. Here I'm going to start with the unit circle, and we'll make links to as many things as possible. So let's talk about a point on the circumference of this circle. Here I chose the angle of pi by 4. So this purple line segment rotated upward by an angle of pi by 4 from the x-axis. Now I want you to concentrate on the coordinates, the x and y coordinates of that point. So this point right here, when we have an angle of pi by 4, so the purple is raised up pi by 4 from the x-axis. The x-coordinate of that point is 0.707 approximately, and the y-coordinate is 0.707 approximately. So the x-coordinate literally means this distance right here. How far to the right is that point from the y-axis? And the y-coordinate literally means the height above the x-axis. Well, it turns out pi by 4 is this angle here, that the cos of pi by 4 is equal to 0.707, and the sine of pi by 4 is equal to 0.707 as well. So the cosine of that angle, pi by 4, literally means the distance to the right that that point is from the y-axis, which is also the x value of the x and y here. And the sine of pi by 4 is literally the height above the y-axis, which is also the y-coordinate here. Now if we change the angle from pi by 4 to pi by 2, like a 90-degree angle, we'll get the same story. Let's try it out. Alright, so here we have now an angle of pi by 2, like a 90-degree angle. And our line now, since it's an angle of, it's going straight, since it's an angle of pi by 2 is going straight up here. So here's our point, 0 comma 1. Okay, so the cosine of this angle, cosine of pi by 2, if you put that in your calculator, is equal to 0. And sure enough, this is 0 to the right of the y-axis. Okay, and the x-coordinate is 0. And the sine of pi by 2 is equal to 1, which literally means that it is above the x-axis by a distance of 1. Here we have the angle of 3 pi by 4, 3 pi by 4, and what is the sine of 3 pi by 4? Well, it's whatever height this is, and it looks like it is 0.707. And what is the cosine of 3 pi by 4? Well, that will be whatever distance this is to the right. Well, since it's to the left, then it's going to be negative 0.707. Anything to the left of the y-axis is going to be negative. Anything to the right of the y-axis, the cos is going to be positive. And for sine, anything above the x-axis is going to be positive. Anything below the x-axis is going to be negative. So I think of the sine of an angle is just the amount above the ground. So you got the negatives down here and the positives up here. Cosine, you get the positives to the right, you get the negatives to the left. So anything in this quadrant, you're going to have positive sine and positive cos. anything in this quadrant, you're going to have negative sine because it's below the x-axis, but you're going to have positive cos because it's still to the right. Over here, it's below the x-axis, you're going to have a negative, whatever the sine of the angle is going to be negative, but it's to the left, so it's going to be a negative for cos as well. So cos of any angle between pi and 3 pi by 2 is going to be negative, sine and cos. And over here, sine will be positive because it's above the x-axis, but cos will be negative because it's to the left. Okay, another way of looking at this is that this is a radius of 1, so that's a 1. So this distance here must be negative 1 over root 2, and this is 1 over root 2. This is actually, I say negative 1 over root 2 because it's to the left, and that distance that way is like negative 1 over root 2, but the actual distance is 1 over root 2, of course, but it goes in the negative direction. So when you think of sine, you think of sine as the opposite over the hypotenuse. So 1 over root 2 divided by 1 is just 1 over root 2. Well, it turns out that 1 over root 2 is 0.707. So it still works out. And the cosine is the adjacent over the hypotenuse, which is negative 1 over root 2 over 1, which is negative 0.707. And that's really why SOHCAHTOA it behaves that way, why sine of an angle is opposite over hypotenuse and cosine of an angle is adjacent over hypotenuse. It's just going over, it's just kind of following this unit circle, and you could always make a triangle with all these points. All right, now we're going to quickly look at the angle pi, 180 degrees. Some of you still think of it, but we're going to try to stop that. And of course, the sine of pi is 0, and the cosine of pi is negative 1. It's always the cosine and the sine if you're following along this unit circle. So this point right here is going to be cosine of theta, sine of theta. And here theta is pi, so it's going to be negative 1, comma 0. Again, 0 because the height, it is 0 above the ground, and the negative 1, the cos, is negative 1 to the right of the y-axis. So if it's on the left, it's negative. This angle is 5 pi by 4, and very simply, the cosine of 5 pi by 4 is negative 0.707. You can put it in your calculator, and that's because it is below the x-axis by 0.707, and the sine is also negative 0.707 because it is to the left of the y-axis by 0.707. Another way to say negative 0.707, to be more exact, is negative 1 over root 2, or root 2 over 2. They both make negative 0.707 approximately. Okay, this angle is 3 pi by 2. Kind of a 270 degree angle. And quickly, what is the sine of 3 pi by 2? Well, how high is it above the x-axis? Well, it's below by 1, so the sine of 3 pi by 2 is simply equal to negative 1, and cosine of 3 pi by 2 is equal to 0 because that's how far to the right of the y-axis this point is. Here's 7 pi by 4, where cosine is 0.707 because it's to the right by 1 over root 2. And sine is negative 0.707 because it's down by 1 over root 2. Cosine of 2 pi is just the same as cosine of 0, which is 1 because it is this point, if you go all the way around the circle, is 1 to the right. And the sine is 0 because it's right on the x-axis. It's not up or down. All right, what about pi by 6? Right here. As you guys like to think of it as 30 degrees. Well, that is a special triangle. There's pi by 6 there, pi by 3 would be here, and this would be pi by 2. And we all know that will be a 1 to root 3 triangle if it were a bigger triangle. But since this is only 1, we know they're all half the size. This is root 3 over 2, and this is 1/2. All right, so that means that the height above must be 1/2. And sure enough, you can see sine of that pi by 6 is 0.5. and the distance to the right must be root 3 over 2. Well, check on your calculator. Is root 3 over 2 about 0.866? Sure it is. So the cosine of pi by 6 is 0.866, or root 3 over 2, and the sine of pi by 6 is 1/2. Let's try pi by 3. All right, same triangle, just kind of rotated. That means this angle is pi by 6, and right here we have pi by 2, just a right angle. And yep, this is a 1, 2, root 3 triangle, but since we know that this really isn't 2, it's only 1, it's a triangle that's half as big. Okay, so the height here, root 3 over 2, height is your sine, and the distance to the right is 0.5. Same goes with the angle 2 pi by 3, where you have that same triangle, and you're going to have cos theta is negative 0.5, and sine theta is root 3 over 2. Same situation for the angle 5 pi by 6, where you got your cos is negative, your sine is positive, because cos is negative because it's still to the left, and sine is positive because it is above the x-axis. And this is all the same thing. I'm just advancing by pi by 6 each time. Here I just thought I'd try an angle of 1. When an angle of 1, I don't mean 1 degree. I mean an angle, a radian of 1. Right? So that's like about, what, 57 point some degrees, 58.7 degrees maybe, something like that. If you look here, the height in that case is 0.54. So if you do the cosine of 1 in radians, you should get an answer of 0.54. If you do the sine of 1 in radians, you should get an answer of 0.841. Okay, and it's as simple as whatever this angle is, the sine is the height and the cosine is the distance to the right. And really look at this triangle. Sine of theta is supposed to be opposite over hypotenuse. Well, since the hypotenuse is 1, we're just saying that the opposite side is the sine, which is exactly what we're saying. Cosine is supposed to be adjacent over hypotenuse. Well, the hypotenuse is just 1, so the cosine of the angle will just be the adjacent side. Here's an angle of 2 radians, so we know that the sine of 2 is 0.909 and the cosine of 2 is negative 0.416. That makes sense. Negative because it's to the left, positive for the sine because it's above. There's cosine and sine of an angle of 3 radians, and notice it's just short of 180 degrees. That's because 180 degrees is pi, 3.14. This is just an angle of 3, just short of 3.14. Remember, all the way around is only 6 radians, well, 6.28 radians approximately. An angle of 4 radians, 5 radians, 6 radians, just short of a full turn, 7 radians, 8, 9, 10, 11 radians, almost at the bottom, not quite. 12 radians, still short of 2 full turns. And there's 13 radians, which is back in the first quadrant. So if you mix up radians and degrees, you might think, oh, that's the sine of 13 degrees. No, that's the sine of 13 radians. You've gone twice around the circle and up. So here I have a different way of looking at it. So I actually have the graph of sine x and cos x on the x and y axis here. I left the circle there, the unit circle, just so you can kind of compare and contrast. Here you can see this is an angle of 0 degrees because I left the dot right here. So the sine at that point will be 0 because it's not above the x-axis at all, and the cosine will be 1 because it's to the right of the y-axis. So when you're talking about the angle for the circle, we're kind of looking at it differently. We're saying 0 degrees, 1, 2, 3, 4, 5, 6 around. Whereas for the actual graph, we're talking this is 0, 1, 2, 3, and so on that way, okay? So we're actually going to start off at negative 2 pi. So negative 2 pi is like negative Let's go around the circle in a negative direction 2 pi, all the way around the circle. So we're back at the starting, but we went around negative. Now what is the sine? Well, it's on the x-axis, so the sine of negative 2 pi should be 0. And sure enough, let's go back to negative 2 pi. Negative 2 pi is about negative 6.28. So we're going to go back to negative 6.28 on the graph. Now notice on the unit circle, we just go backwards a full turn. That's negative 6.28 or negative 2 pi. But on the graph, now the x-axis is actually what we're talking about for the angle. So this, we're going back negative 6.28. And sure enough, it is right on the x-axis. It's on the x-axis. Now for cosine, again, the angle, we have to go around. On the unit circle, we think, okay, we're going to go backwards 2 pi. And what is the distance to the right of this dot? Well, it's 1. It's positive 1. Now, for the graph, we're not going to go around. We're going back 2 pi. So we're going to go backwards 2 pi. And the height, we have to put as 1. So this is the cosine. It's 1. So basically, the height of this curve is telling us how far to the right it is here. So what about cos and sine of 45 degrees, or pi by 4? At pi by 4, if you notice, this is a triangle with, pi by 4 here, pi by 4 here, and 90 degrees here. So these angles are the same. The sine and these sides will be equal. So the sine and the cosine of 45 degrees, or the sine and the cosine of pi by 4, are equal. And they're actually equal to 0.707 approximately, or 1 over root 2. And if you go back to that same angle, no, excuse me, we're actually still in the negative. So this is actually negative 1 pi by 4, 2, 3, 4, 5, 6, negative 7 pi by 4. So negative 7 pi by 4. If you put in negative 7 pi divided by 4, you're going to get negative 5 point something. It's going to be right here. It's negative 7 pi by 4. And cos and sine are both at positive 707. So you see that the cos is 0.707 and sine is 0.707. They actually meet right at that spot. Okay, here's the angle that you guys know as 120 degrees. But we should all know now that that's actually equal to 2 pi by 3 and when you're talking radians. At that point, the sine is just the height above the x-axis, so that is a positive number. It's 0.866. And if you look back at, oh, excuse me, I just realized we're not supposed to be doing 120 degrees. We're still in the negative, so we're actually at negative all the way here. Let's say 180 plus 60, negative 240, or negative 4 pi by 3. We're still in the negative, so we're still on this going backwards, negative 4 pi by 3. But it's going to be the exact same thing as positive 2 pi by 3. As you can see, the point still ends up in the same place. So the height is 0.866, and if you look at my sine curve, sure enough, it's at 0.866 at negative 4 pi by 3. And the cosine is negative 0.5 because it's on the left, so it's negative. And so here, the value for the cos is negative 0.5. So if you notice, like if the cos curve is below the ground, that means that this circle must be to the left of the y-axis. If the cos curve is above the ground, that means this circle must be to the right, or the point on the circle must be to the right, because this is the positive area and this is the negative area. For the graph, this is the positive area and this is the negative area. For sine, it's a little easier. When sine is above, it's because the point is above the ground. When sine is below, it's because the point is below. So as you watch this dot kind of go around the circle here, just notice that the sine curve, the dot on the sine curve is always the same height as the dot on the unit circle, whereas the dot on the cos curve is always the distance above the x-axis that the dot is on the unit circle to the right, the distance to the right of the y-axis. And as it goes down under the x-axis, it's because the dot on the unit circle is to the left of the y-axis. So this this blue curve is really telling you how far to the right the dot is, how far to the right of the y-axis. So when it's up here, it's the farthest to the right. When it's down here, it's the farthest to the left. As it's going down, that means the angle is changing going towards the left. And as it's going up, that means the angle is changing going towards the right. So if you follow this angle along like this, then you'd be following the circle going, right now you're the farthest to the right, so that would be the circle going that way around. Okay, just take a couple, just kind of take a look here at a couple points. If I have an angle of 90 degrees, well, that would be right here where sine is at its highest point and cosine is at 0 because it's right on the y-axis. If I go to 180 degrees or pi, well, right at pi, now sine is 0 because it's on the ground, whereas cosine is -1 because it's to the left. And pi is about 3.14. You'll notice that this spot right here is at exactly pi. So 3.14 approximately.